Distinguished colleagues, good afternoon. It's February 12th, 2020, the year 2021. It's 12 o'clock noon, and we're beginning the panel session for the defense of the thesis by Dmitry Tumakov. And I am to announce the first technical break because we are waiting for one of the members of the board. Yes, so I announce a technical break for 10 minutes. So, dear colleagues, we are finishing our first technical break and we continue our session. As I've already mentioned, we're beginning the panel session for the defense of the thesis by Dmitry Tumakov. The thesis is submitted for the academic degree of the candidate of sciences in physics and mathematics. The specialization is 010402, theoretical physics. The topic of the thesis is the calculations of total and differential ionization probabilities of atoms and ions exposed to short laser pulses. So, under the order issued by Alexander Gnatov, Academic Secretary of St. Petersburg State University as of December the 2nd, 2020, number 10927/1, I, Oleg Andreev, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Quantum Mechanics of St. Petersburg State University, have been appointed the chairperson of this dissertation board. The order also approved the candidacies of the members of the board, and let me introduce them. Ilya Topitsyn, Doctor of Sciences in Physics and Mathematics, Senior Researcher, Professor of the Department of Quantum Mechanics of St. Petersburg State University. Vladimir Rohin, Doctor of Sciences in Physics and Mathematics, Senior Researcher of the Center for Advanced Studies of Peter the Great, St. Petersburg Polytechnic University. And the following members of the board are working remotely today. Andrei Nefedov, Doctor of Sciences in Physics and Mathematics, Senior Researcher of the Konstantin of St. Petersburg Nuclear Physics Institute of NRC Kurchatov Institute. Do you hear us and see us, Andrei? Oh, we don't hear you? Yes. Yes, I do. Okay. Okay, the answer is yes. Andrei Surzhikov, Doctor of Sciences in Physics and Mathematics, Head of the Fundamental Physics for Metrology Institute of the Braunschweig University of Technology from Germany. Do you see us and hear us? Yes, yes I do. Good morning. Glad to see you. Wonderful. And we also have our candidate for the degree, Dmitry Andreevich Tumakov. And we also have the Thesis Supervisor, Vladimir Shabayev, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Quantum Mechanics of St. Petersburg State University. So, do you see us and hear us? Yes, yes I do. Okay. Distinguished colleagues, in order to improve the quality of our connection, kindly turn off your microphones, but do not forget to turn them on when I give you the floor. I would also like to inform you that the panel session of the dissertation board is being recorded and broadcast on the St. Petersburg State University website, and it is also interpreted from Russian into English or from English into Russian. And currently we have an email address posted on the page with live broadcast of the board session, and all listeners can submit their questions to Mr. Tumakov online. The questions regarding the thesis or scientific discussion. These questions will be forwarded to me by our technical service, and I will read them out during the discussion. Questions must be related to the presentation or the thesis, and do not forget to give your name and position if you submit a question. Questions that have nothing to do with the scientific discussion or dissertation or the text of the thesis will not be voiced. Under the order on the procedure of granting academic degrees at St. Petersburg State University approved by local normative acts, the session of the dissertation board is valid, providing 2/3 of the appointed board members are present. The total number is not to be fewer than 4 people. The dissertation board consists of 5 people. Everyone is with us today remotely, including 2 members of the board. So everyone is with us today, including 2 members of the board who are working remotely. And we have a multimedia connection with everyone. Therefore, we have a quorum. And the agenda for today's session is as follows. It should not last more than 2 hours. And first comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. And chairman's replies to questions, if any. Second, the candidate's presentation providing an overview and findings of the research, 15 minutes for that. Third, questions to the candidate regarding the presentation, no more than 2 minutes for each question. Fourth, the candidate's replies to the questions, no more than 10 minutes for all. 5. So fifth article, reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions to the candidate for the degree, 10 minutes per speaker. Next comes the chairman's report on the thesis, 10 minutes for that. Next, the candidate's comments about the reports on the thesis and replies to questions, 20 minutes for that. Next comes open discussions, everyone willing to speak out and give their short reviews or ask questions on the topic of discussion, 2 minutes for everyone willing to speak out. And I kindly ask you to fill in the registry form and introduce yourself before you are given the floor. Next comes the Article 9. The chairman will ask the questions submitted during the broadcast via our website. Then, candidates' replies to the questions, 2 minutes per question. Then, a presentation of the candidate's thesis supervisor, 3 minutes for that. Then, a 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. And the discussion of the results of the defense is not broadcast. Then, open balloting, vote counting and recording the results in the protocol. Next, making a decision on whether to confer the academic degree or not. And finally, we will give the floor to the candidate for the closing speech, no more than 2 minutes. Any questions or comments on our agenda, dear colleagues? Okay, no objections, therefore let me start. But before I proceed, I kindly ask you to switch off your mobile phones. Thank you. So, the chairman's presentation. The thesis by Dmitry Tumakov for the academic degree of the candidate of sciences in physics and mathematics, Specialisation 010402, theoretical physics, is titled Calculations of Total and Differential Ionization Probabilities of Atoms and Ions Exposed to Short Laser Pulses. The thesis was approved for the defense by the order of the academic secretary, Mr. Gnyatov, issued on April 14th, 2020, number 1087/4/1. Mr. Tumakov has prepared his thesis based on St. Petersburg State University, and Professor Vladimir Shabayev, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Quantum Mechanics of St. Petersburg State University, is the thesis supervisor. The list of 3 published works describe the research findings. They include no papers published in peer-reviewed journals recommended by the Ministry of Education and Science, and 3 papers in publications indexed in Web of Science and Scopus. The candidate has submitted the full set of documents to Alexander Gnyatov, the academic secretary of St. Petersburg State University. The above-mentioned documents comply with item 12 of section 3 of the order, and all the documents submitted, as far as I'm informed, correspond with the requirements, and they are found in the certification file. And the curator of the defense, member of the Department of Dissertation Board Support, has all the copies. Before I give the floor to our candidate for the degree, distinguished colleagues, I would like to ask you if you have any general questions to the candidate for the degree, and is there a need to consider the whole list of documents submitted for the defense? Okay, no questions. So, short report of our candidate for the degree, 15 minutes. So, Dmitry, please, you have the floor. Distinguished colleagues, good afternoon. I will shortly tell you about my thesis. You see the title on the screen. The field of study was to find the interaction with atomic targets, and this work was headed by Vladimir Shabayev and Dmitry Telnov. So the short plan of my report is as follows. First of all, I'll start with a short introduction, then I'll give you the general methods that were used for the calculations, and I will give some basic results, and in the end I will tell you about the provisions taken for the defense. So the most recent achievements in laser technology arise a lot of interest to theoretical and experimental studies of different physical processes when we have external extreme fields, and in particular of particular interest are the processes of interaction of short impulses with molecular and atomic targets. And such studies are important for many reasons, both for fundamental reasons and for applied as well. For example, such experiments help us get information on the target parameters, and also contemporary opportunities give us an opportunity to develop attosecond physics that studies electron dynamics and molecules on attosecond scale. Rescattering of photoelectrons can be the source of coherent irradiation, high energy irradiation, and this process is called the generation of high-level harmonics, high-order harmonics. So QED tests are used here, as well as the calibration of extreme fields, because these fields are becoming so intensive that we can't measure them with ordinary methods. So theoretically, we can describe such processes in a different way. For example, here on the slide you see the groups of methods that are most widely applied today, and many results were achieved within decades. If we talk about the approximation of strong fields, and something can be described qualitatively and quantitatively using semi-classical approaches. But in order to take into account all the facts, we need to use the numerical solution of Schrödinger Dirac equation, and that is done numerically. So if we're talking about multi-electron targets, then in case of 3 electrons, it is impossible to calculate correctly. Therefore, we use different approximations. For example, single active electron approximation, or we can use the density functional theory. We'll get back to that later. So let's dwell upon the modulating of the laser field. We use dipole approximation, and vector potential depends on time only, and the field is electric, exclusively electric. And if we talk about applicability, there is an obvious applicability margin. The target size should be small comparing the laser pulse, and there is an impact of magnetic component on the photoelectron dynamics. And in particular, it is important to consider the rescattering process, and if the trajectory is distorted due to the magnetic field, this approximation may not, this rescattering may not happen. Yet in our work, we use Lorentz parameter, or Lorentz deflection parameter in order to assess the impact of the magnetic field. Well, depending on the character of the process, the electron dynamics is described by Schrödinger or Dirac equation, and the dipole approximation can be used to work in equivalent calibrations and gauges for velocity and length. They can give different results, but that's a good test for adequacy and for accuracy as well. So let's shift to methods of numerical solution. We are resolving them in final volume of R radius, and we are looking for the function when we use the expansion, basis set expansion. So our goal is to find the vectors, and matrix differential equations are also used here. So in order to calculate the probability, full and differential one, after the external field is turned off, we can use the following formulas. When we manage to get a full wave function at tau point, that's rather a remote point. So you see psi e and psi minus. These are the functions of non-perturbed Hamiltonian. And unfortunately, we are not always able to get the full wave function because we have a range of scales, spatial scales that may be different by orders. This enhances the requirements to the size of the box and to the frequency of spatial discretization. And in case when these scales are not that different and when we are unable to construct them, we use the absorbing border. And you see the drop of the interval. And this drop can be interpreted as the probability for ionization. Let's shift to major results, to the main results. First of all, let us consider the relativist calculations of the total ionization probability for argon-like systems. Inter-electron interaction was calculated within the density of functional theory. So we had time propagation of a direct sham orbital, and the calculation was carried out in two regimes: when this potential was time dependent and when it was time independent, and when it was when we had this frozen core approximation. And we see that the results combine quite well with the results from the literature, non-relativist results. And as for the probability development, it is explained by the fact that polarizing the core screens the external field, and this effect is not taken into account if the screening is equal to the initial one. So this similar calculation was carried out for argon-like xenon ion, and here the difference between relativist and non-relativist calculation is quite obvious, which is clear because the xenon charge is much higher, and we see additional effects here. Next process that we considered is resonant lithium resonant ionization. So the slide gives us the result of the generation process for high-order harmonics. We used photoelectron spectrum, and instead of density functional theory, we used the approximation of single electron, which seems quite relevant. And this approximation allows us to reproduce the transition energies and dipole matrix transition elements near the initial stage, which is important for the consideration of the overall resonance process. And essentially, for not so strong fields, that's a two-tier system, and we have Rabi oscillations, and you see them on the screen. And it turns out that oscillations of occupation leads to the fact that we have certain interferation in electron spectra, and you see the widely pronounced minimums A and B. And these spectra were well studied, and the distance between them was equal to the appropriate Rabi frequency with certain accuracy. And it should be mentioned that this picture is not a specific one for lithium, because we may have it in other systems as well when we have the similar electron structure. And as for the final stage, we needed to study the relativist mask method, and we did not have the opportunity to get the full wave function. And in non-relativist studies, there's a wide use of space differentiation method when we have coordinate and impulse scale, development simultaneously, and in the pulse scale we neglect the core interaction. And my work offers a relativist modification for this method, and this work was demonstrated on 2 examples. The probabilities here are calculated like that. You see this beautiful F, that's Fourier transformation on coordinates in the B sphere during at the tau point. And as a checkup for that, I would like to compare with non-relativist calculations. And we know that if the external field is not that large, the main contribution to these differences between relativist and NR approaches happen due to the change of ionization potential, and we carried out non-NR calculations with scaled Z, a definition that eliminated this difference. And in particular, this is the calculation of spectra for hydrogen-like xenon atom, ion, and we can see that this method works well, especially in cases when we can use calculations by expression, so we can check them like that. And as for conclusions, here you see the provisions taken for the defense. So we developed and checked the method for relativist calculations of the ion probabilities for many electron systems. And we also studied the interferation picture that emerges in photoelectron spectra in a resonant ionization regime, and we offered a relativist method for the calculation of the spectra of angle distributions that does not require the understanding of full wave function after the interaction is turned off. So here are the conferences and publications that gave the results, and that's it. And that's, you see, the combination of words from the thesis presented as a car. Okay, thank you very much. The questions on the report that gives the major provisions of the thesis. So please, the questions. The question or the remark. Without the knowledge of the wave function, this method, you know, as if you know it, the method does not work. I believe you should replace these words by the words without the use, rather than without knowledge, without the need, because this is the provision taken for the defense. Therefore, I believe you should formulate it more accurately. I've paid attention to that when I read the thesis as well. Thank you. Other questions, if any? May I? So, please, yes. The question that I wanted to ask when I read the thesis, when Dmitry mentions the difference of SAE model and Dft model, Dmitry, I have an impression that there is a kind of opposition between these methods, but that's the same. These are the same methods. The question is, what is the approximation in which we generate single electron orbitals? For example, we can use Dirac or Schrödinger equations for these charges, and we can use a more advanced method like DFT. So once again, that's a terminology issue. For me, that's CIE approximation. It includes the orbitals that are being generated by the functions. or you are referring to a different point here? Thank you very much for the question. Within the framework of DFT, when I mentioned that we're working within the DFT framework, the wave function is a multi-electron one, and it is based on single electron orbitals, not that are not in interaction with each other, and not a single of these orbitals meets the real particle. And this wave function does not satisfy the Schrödinger or Dirac equation. So everything that we can say is that we hope that the density that we get when we use such an approach will correspond to the real density. But overall, multi-electron character here, it is ingrained at once, and we have this Pauli principle as well. Well, the thing is, single electron wave functions, they are in slighter determinant as well, certainly. Yes, but when we talk about the approximation of single active electron, there is one orbital and one wave function, and it really corresponds, as we believe, to the real electron, the physical electron. So the goal here is one electron goal, and Pauli principle is not met here, and the transitions to occupied states are possible. So the difference is as follows. Okay, I got it. SAE approximation for you, that's single electron without Slater determinants addition. Yes, for K shell. Yes, I got it. Thank you. I would add a bit. In single electron case, your density is frozen. Yes, it does not change in time, electron density. And in DFT, it depends on time and is recalculated. Is it? Is it so? In DFT, we make both, and if we freeze it, it really resembles the SAE approximation. Yet, the potential is calculated by a more complicated method. So that's a different approach. Okay, any other questions? Okay, I will ask one. That's the question on the thesis rather than on the report. In the thesis, you use two methods to describe the time propagation development, Crank-Nicolson and split operator method. What is the principal difference between these methods? And maybe for the sphere in which they are both applied, we can say that in changing methods we can't improve the accuracy. Thank you for the question. Indeed, one of the methods, split operator method, is actually the multiplication of matrix to vector, and each time step happens at the same time. And if we use Crank-Nicolson, we have linear equations on all the steps, and each step takes longer. And above all, we have a more technical point. A split operator method can be used to secure this use of memory. And as for accuracy, we can improve the stability, and Crank-Nicolson method is a unitary one. And if we work with density functional theory, any mistake in the wave function that is inevitable, because we numerically resolve the problem, it will introduce a kind of density defect, and density is recalculated and adds up to the potential effect, and the stability is of primary importance here. And in split operator method, it's not a unitary one, depending on the commutation of operators, and this non-unitary character can be rather significant, and the stability does not change. So it's hard to see. That's quite a long talk about the choice. So we should look at what happens, look at the number of photons participating in the process. We should consider whether it's a relativist or an NR process. So we should have an opportunity to use both methods. Okay, and split operator method, when is it preferable? more preferable. For example, if we talk about relativist calculation, we have 4-component wave function, and we have one coordinate of phi that is divided and remains into radial and data angle. We see that the scale goal is quite significant, and we can reduce it if we use the wave function that is expanded. And in split operator method, we can shift from large matrix goals to a range of small matrix problems. And this has an impact on the time of calculation, but that's a more preferable, more preferred method for relativist calculations, especially when we're not talking about the dipole approximation. Okay, thank you. Any other questions? Okay, no questions. Let's shift to the next part of our session that talks of the members of the board with their reviews on the thesis, offers and questions to the candidate for the degree, and external reviews. And you can answer the questions step by step or at once after all the reviews are voiced. I believe it would be more preferable if you answer step by step. Okay. And now external reviews, am I right? Yes? Okay. So the members of the board then. As all reviews were already published on the St. Petersburg State University website, I offer to give just the major provisions, questions or remarks. Do you support this idea? Yes, okay, thank you. And so the order is as follows. Mr. Topitsyn, you are the first. Good afternoon. My review has several paragraphs, and I'll just say a few words. I won't read everything because the review was already published on the website. And the first thing that I would like to mention is that the work of Mr. Tumakov is dedicated to the theoretical study of the multiphoton ionization processes. We've seen it in the report as well, and the goals are quite fundamental and important, and contemporary physics goals are well illustrated in the work and in the content of the report. The work is quite relevant, and it has scientific novelty and value, and the methods of numerical solution of Dirac and Schrödinger equations using program codes have practical value as well. The thesis is made up of 5 chapters. The first one gives the method of numerical solution for Schrödinger and Dirac equations using Lagrange polynomials basis. Second chapter is dedicated to the calculation of probabilities of full probabilities of relativist targets, and 3 other chapters are dedicated to the calculations of differential probabilities using 2 different approaches. And above these general words that I miss on the content of these chapters, I would like to mention the following fact. There are certain interesting results that the author obtained. I would also like to mention that the author uses state-of-the-art algorithms that improve the efficiency of these methods if we talk about the Dirac and Schrödinger equation solutions. And I would like to emphasize that he uses Pardis algorithm in order to resolve the linear equation systems with uncharged matrices. This improves the Crank-Nicholson solutions by an order, and that's a know-how, the contemporary use of such new algorithms. And as for the remarks, first of all, I would like to mention that essentially I have no negative points that would compromise the value of the results, the importance of the results. But there are certain drawbacks and certain questions that may arise. So I'll shortly list them. I have 5 of them. These are some insignificant points. On page 13, the author writes that the Lagrange polynomial basis preference is the fact that the matrix of any operator is a diagonal one. That is so indeed if the integration is carried out with the calculation of matrix element, and it is carried out with approximated formulas with the use of mesh points as integration nodes. If we change this approximated formula, this won't be the case. Next, page 24. It's unclear why do you introduce second order matrix, because you're talking about H0 radial operator, direct operator. It becomes 4 component and influences 2 component radial functions. That's how I got it, at least. Then in relativist calculations of eigenlike xenon, you use non-relativist that's a question. Did you use non-relativist expression for the exchange correlation component? Can you assess this error somehow? I believe you should have tried to consider the relativist corrections here. And 4th remark is that in section 5.5 you discuss the issue on the applicability of dipole approximation, the calculations of probabilities of multiphoton hydrogen atom ionization, as well as for hydrogen like xenon atom. And it's unclear for me, what do you mean by this insignificant deviation term when you talk about this application of Lorentz force, and why is this condition performed if Lorentz parameter is much less than 1? And can this condition of insignificant deviation be formulated in the terms of quantum mechanics? Because I know that you use this classical language here. And finally, the 5th remark. Initial significance of the projection of the full electron moment m is considered equal to minus 1. I thought it should be minus 1 half. On page 46 you missed this sum on m projection in 103 formula. In relativist case you should have the sum on the states with not with energies higher than 0, but for energy higher than C taken to the degree of 2. And finally, for the expression for evolution operator is approximated because Hamiltonian operators do not commutate at different points of time. And what else do I like to mention is that the results are published in 3 high-ranking international journals, and along with the use of state-of-the-art methods, we see the demonstration of the credibility of the results. And Mr. Tumakov is always the first author in his publication, and this demonstrates that he had a major input. And overall, I should mention that the thesis is performed at a high scientific level, and it is a finished research work, and it is of particular interest from the theoretical point of view, and I believe it should be further applied in further studies if we talk about the laser fields. And the finalizing review, I will read it out because it's important. I believe we will read just the same. Maybe the colleagues won't read that after I do that. The thesis by Dmitry Tumakov, titled Calculations of Total and Differential Ionization Probabilities for Atoms and Ions Exposed to Short Laser Pulses, meets the requirements of the order as of September the 1st, 2016, on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Tumakov deserves the academic degree of the candidate of sciences in physics and mathematics in specialization 010402, theoretical physics, and the Article 11 of the above-mentioned order is not violated. Thank you. So, please, Dmitry. Thank you very much for the review. There are 2 questions and a number of remarks. I agree with all the remarks, indeed. Unfortunately, I did not manage to correct all the misprints. But as for the questions, and the question on calculation of full probabilities for eigen-like systems. Indeed, I used non-relativist efficient potential type. And as for field parameters and target parameters, they demonstrate that if there is any difference, it will be mostly connected with a shift of ionization potential with the results of the time-independent problem, and there is a relativist modification of the LDA potential, which is part of the one that we used in our calculations. And here I carried out calculations, and the shift of energy of this interesting high-lying states made up 1/3 of the photon energy of the external field, and considering the fact that there were 20-something photons in the process, we can't see that there was a reflection on the full probability, but if we would calculate the spectral, we would have observed this shift. As for dipole approximation and Lorentz parameter, I believe we should first of all mention that if in the left margin and high wavelength, considering the target scale, it's more or less clear. Here I'm referring to the application borders and limitations. As for the right border, there are a lot of candidates for this most adequate parameter that would allow us to assess the geomagnetic component of the pulse on the process. And we've chosen the Lorentz parameter, and it is characterizing the probability of photoelectrons when we have rescattering. So that is the probability to miss the core. So without the classical theories, we are unable to introduce it using this quantum mechanics language, as you mentioned it. Yet, if we believe that the wave vector of the external field of this current charge is going through the along the z-axis, where the Lorentz parameter is, we can demonstrate that for tunnel ionization, that if we model the distribution of density of photoelectron along this z-axis as a Gaussian, its initial width at the ionization point is defined by a correlation of by indefinite correlation in this case. Certainly this wave package will scatter in time, and if x equals 0, our wave package will return. Yet we would like to see its width overlap, so that its shift along the z-axis would be no higher than its width. And this, the square of this expression, gamma y, And this dependence on the external field parameters demonstrates that if the field is strong, then Lorentz force is strong, and we can't ignore it. And if the wavelength is high, it will turn out that the electrons are flying too long before returning, and we can't neglect that. And as we see it in the literature, there's this recent article of Dmitry Alexandrovich, and dipole approximation for full ionization probability for hydrogen-like system was not that applicable when the Lorentz parameter was 5 multiplied by 10 in minus in the degree taken to the order of -3. So classical formulation is something quite complicated here. That's it. That's the answer. Ilya, are you satisfied with the answer? Yes, yes I am. It became much clearer. Okay, now I give the floor to the next speaker. That's Vladimir Anatolievich. Dear colleagues, good afternoon. I'll read out my review with certain corrections in order to take that so long. So the thesis is dedicated to the theoretical study of the processes of atom interaction with highly intensive laser field, and this field of physics is quite relevant, and it is developing quite quickly, which is explained by the progress of laser installations and the emergence of high-intensive, short coherent impulse generation technologies development. And in order to describe these experiments, we need to use numerical methods for solutions depending on time. If we talk about the Dirac and Schrödinger equations, and analytical methods give us very rough approximation, and they can't give us the quantitative results. And this thesis is aimed at the development of such numerical methods, and thus it is quite relevant. A thesis has the relativist method of calculation of full and differential cuts of the ionization processes for multi-electron atoms or ions in the field of laser pulse, and inter-electron interaction is considered within the framework of the density functional theory or inefficient single electron approximation, and these methods are applied for the computation of probabilities for argon and argon-like xenon, and the relativist calculation method for angle and energy distributions of photoelectrons that does not require the computation of wave electron function in the final state is also demonstrated, and the efficiency of method is shown for 2 different scenarios for hydrogen-like ions, and also the calculation is done for the process of lithium ionization in resonance regime. The validity of the results is supported by the use of state-of-the-art equipment, and it is also supported by the results of calculations published in literature. And the results were published in 3 articles in international journals, and they were reported on international conferences. So then a few words about the chapters. I'll skip it. And overall, the work is the thesis is written quite well, though it has certain style and punctuation problems. And as for the content, when we read the description of processes in chapter 1, it's still unclear where the applicability of this method stops. It would be useful to discuss the applicability here in more detail. For example, it's clear that if we use the solutions for dynamic equations in coordinate representation, we won't adequately describe the ionization process for a deep tunnel regime. Second point, when we discuss the methods of inter-electron interaction in chapters 2 and 4, it is unclear how did you choose, how did you make a choice between the density functional theory and the single electron model. So it would be interesting to compare the results of two methods. And third point, the smooth mask function is used for two goals: to exclude the non-physical reflections of box border and for smooth transition to propagation and impulse space. And we can't understand at once that these are different functions and requirements are different. And these remarks do not compromise the major results of the work, and they as well as the overall positive impression of the thesis. And finally, I should say that the thesis of Dmitry Tumakov, titled Calculations of Total and Differential Ionization Probabilities for Atoms and Ions Exposed to Short Laser Pulses, meets the requirements of the orders of September the 1st, 2016 on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Tumakov deserves the academic degree of the candidate of sciences in physics and mathematics and specialization theoretical physics, and Article 11 of the above-mentioned order is not violated. That's it. Thank you. Thank you very much for the review. Thank you very much for the valuable points. As for the applicability question, indeed, in the tunnel regime, it's hard to calculate probabilities like that, and I should have written that in the text, I believe. For us to calculate anything, we should take into account the number of photons participating in the process, because each new photon and dipole transition provides for the opportunity to change this orbital or full point by an order of 1. And for us, this means that we need to improve the discretization frequency, and at some point we won't be able to calculate anything. If in NR approach we will be able to have a 100 photon process, but in relativist approach that's several dozens is the maximum. Then a question on the choice between Dft and Sae. Well, first of all, this choice should be explained by the structure. In case of lithium, certainly the structure is quite suitable for that. Considering its shell, and we should also consider the process character, because for lithium-like system, lithium-like ion, we can choose the external field parameters so that for laser S shell will be inaccessible for ionization, but ionized 2s electron will just rescatter and push away the electrons from 1s shell, and in this case single electron goals won't be resolved. So the overall conclusion is that there are major fields, but in fact we should consider the process individually. And as for masks, unfortunately the wording is not that good. When we talk about eliminating some physical reflections, this smooth function really has no requirements, no additional requirements. But if we talk about the transition from propagation to coordinate impulse space, here we see a range of, and in the number of articles, scientists studied the adequacy of this transition when we had different parameters of this function, and it turned out that it's important to consider the electron energy, because for different electrons this transition should be different. Well, that's basically it. Okay, thank you. I'm satisfied with the answers. Okay, dear colleagues, everything okay? Andrei, please, you have the floor. Professor Nikolov. Andrei, we don't hear you. Yes, do you hear me? Okay. So once again, good afternoon, dear colleagues. As for my review, I won't read it out because you have it on the website. But I'd like to mention that the thesis by Mr. Tumakov is dedicated to the calculation of probabilities for atom ionization when we use short laser pulses, and the relevance is defined by the need to understand these processes in applied and fundamental studies. The calculations of differential parameters of the ionization process allows us to get information on the internal structure of the targets and on the process as well. Then the progress give us a new field of development of attosecond physics, and the goal here is to study the electron dynamics and the management of these dynamics at the attosecond scale in atoms, molecules, and bodies. And the main instrument here is the impulse of coherent radiation, and the results can be used to check quantum electrodynamics and ionization of multi-charge ions of heavy elements that have a huge electric field of the core is of particular importance, and such experiments will be possible in the near decades, and certainly this demonstrates the relevance of this work. The thesis consists of an introduction of 5 chapters and annexes, and as for materials, they were published in 3 peer-reviewed journals. There were 3 articles and 3 testings at the international conferences. So the text of the thesis is a rather good one, though I have certain comments on it. First, the current state of the studies is given too shortly in the introduction, and in particular shortly mention analytical and semi-analytical methods of the description of ionization processes that are widely used today for qualitative and quantitative results. In the second article, you have these different approaches of discretization of Schrödinger and Dirac equations within the framework of pseudo-spectral method. I believe it would be more convenient to add up the table with computational difficulties. Third, you use a lot of abbreviations with explanations, and there are a lot of duplications in the text. When you describe the resonance process for lithium atom, you mentioned that you use not just trapeze model, but also the real curve square sign model, and as a result you give a range of spectra, and maybe you should have given less curves or give a more detailed description here. Chapter 5 is dedicated to the relativist calculation method for photoelectrons, but you give no technical details of computations that would demonstrate the efficiency of this numerical procedure. And the problem of the applicability of dipole approximation should be discussed in detail, but you mention it due to some specific calculations in your work. And certainly these comments do not compromise the high value of this work. And this is by Dmitry Tumakov, titled Calculations of Total and Differential Ionization Probabilities of Atoms and Ions Exposed to Short Laser Pulses meets the requirements of the Order on the Procedure of Granting Academic Degrees at St. Petersburg State University, and Mr. Tumakov deserves the academic degree of the candidate of Sciences in Physics and Mathematics and Specialization in Theoretical Physics. Article 11 of the above-mentioned order is not violated. That's it. Thank you. Thank you. Thank you very much for the review. For the comments, I agree with all of them. And as for the questions, I believe I heard none. Therefore, I just agree with your comments. And as for the structure of the thesis, really the description of dipole approximation is something that I should have given in more detail. And as for the introduction, indeed, I should have added a certain review of semi-analytical methods. That's it, what I can say. Okay, Andrea, are you satisfied with the answer? Yes? Okay. Now I give the floor to Andrei Surzhikov. Dear colleagues, once again, good afternoon. I won't read out, and I'll shortly say, certainly I believe that the work is a very high quality one. I believe that the topic of study is quite relevant, and I believe that the development of numerical solution methods for Schrödinger direct equations is an important one, is an important topic for experiments, because today we have a lot of experiments underway in Hamburg, and that is a benchmark for theoretical stages. As for the work itself, as for the study itself, I believe that the thesis is written quite well. There are certain insignificant drawbacks that the colleagues have already mentioned. I had several offers rather than criticisms. The first offer I was already mentioned. It seems to me that you should have defined the terminology in more detail and give more description of the methods for single electron approximation and multi-electron approximation, so that we would understand which method is based on what. And overall, it seemed to me that multi-electron theory is a bit separate from other ideas. So it would be interesting to discuss it for relativist calculations of energy angular distributions. Once again, maybe it's just an idea that I missed. Maybe it was already described in the text and I missed it, that this multi-electron theory development would be... So it would be very nice to see this discussion of multi-electron effects. And as all the colleagues, I would like to mention that dipole approximation is wonderful, but it would be good as well to discuss the advantages and disadvantages of this method, and it would be interesting to discuss it as a plan for the future. Maybe you can go beyond these borders of dipole approximation based on the methods that you applied. So this would be interesting. It's not necessary to implement it right here, right now, but it would be interesting to discuss them. And as my colleagues, I would like to mention the high value of this research, and I would like to mention that the publications were done in high-ranking journals, even the most recent ones, and there are already references on these publications. And once again, I agree with the colleagues that the thesis meets the requirements of the order of St. Petersburg State University on the procedure of granting academic degrees, and I fully believe that Mr. Tumakov deserves the academic degree of the candidate of sciences in physics and mathematics. So that's what I wanted to mention. Thank you very much, Professor. Thank you very much for your review. Certainly I agree with all the remarks that were already mentioned on the difference of these two approximations, Dft and Sae. Indeed, in the text I should have added more explanations on that. And as for this connection between the calculation of differential probabilities and the work with multi-electron systems, you're right. So I should have done it. But the thing is that in non-relativist science, these calculations have long been underway within the framework of this approach, when the space is divided into different propagation sectors and we propagate different orbitals, quantum orbitals, and calculate the sum angular distribution of a differential probability as a sum of probabilities received from different quantum orbitals. And in relativist sphere, I know nothing about such spheres, but I believe I should have studied it in detail. And as for the transition to non-dipole calculations, the main difficulty here is that this scale changes from 1 plus 2 to 1 plus 3, and this really expands the time of calculation and requirements to computational equipment, and that is an ongoing process, and I hope that these methods will not change. And it's really great that we have an opportunity to choose the method that we like. And the development of dipole methods allows us to move forward. That's it. That's it. Andrea, are you satisfied with the answer? Yes? Yes, I am. Okay. And fifth review is my review. My review is also a positive one, and I'll just read out a few words. So the thesis of Dmitry Tumakov is dedicated to the study of interaction of atoms and ions with short laser pulses. And as my colleagues, I would like to mention that the work is quite relevant, and quite recently optic technologies had a lot of advances, opening up new fields of atom, molecular, hard body physics and chemistry, and we have an opportunity to carry out highly intensive laser radiation experiments. And within the framework of the thesis, we see the development of a range of methods to calculate differential probabilities of atom and ion ionization with the impact of laser radiation, and these are relativist methods. So, and the relevance is defined by significant progress in the study of such processes. Then I describe the chapters and say that the methods used are quite advanced, therefore the results are credible and valid ones as well. And in conclusion, I'd like to say that the thesis gives us the relativist methods for the description of ionization of ions and atoms by strong laser field, and it allows us to describe the range of processes of interaction of atoms and ions, and the thesis is a significant contribution to the theoretical study of such processes. The thesis is written quite well, though there are certain remarks that do not compromise their high mark. First, the results of the application of the developed methods are not compared well with experimental data. And second, in the end of the chapter 2, you make a conclusion that the consideration of the dynamic response of multi-electron target to external field can reduce the probability of ionization. This conclusion is not an obvious one, and in chapter 3, you don't give the results of the numerical calculations, and you don't give us the origin of the psi function in formula 99 and 100. So you need to guess here. And in conclusion, I also write that this is by Dmitry Tumakov, titled Calculations of Total and Differential Ionization Probabilities of Atoms and Ions Exposed to Short Laser Pulses meets the requirements as of the order as of September the 1st, 2016, and Mr. Tumakov deserves the academic degree of the candidate of sciences in physics and mathematics and specialization in theoretical physics, and Article 11 of the above-mentioned order is not violated. So, please. Thank you very much for the review, Professor. The results are indeed not compared with experimental results. Certainly that would make the thesis more interesting, but unfortunately I would have to sacrifice something else, because the most interesting experiments for us were relativist experiments, and there are not quite a lot of them. With intensive fields we don't have them at all, but I hope to see them in the future. And as for non-relativist calculations, they were a kind of instrument to move here, to move closer to a relativist field. Therefore, we didn't have this comparison. So, and as for the ionization probabilities, which is low if we take into account the electron dynamics, there are two facts here. And which one of them is a decisive one, it's hard to say. One of them is just polarization of the core, which is partially screening the laser field. If we talk about high-lying electrons, and certainly there is this effect that due to the fact that ionization happens, the screening becomes weaker because we have less electrons that screen the charge, and with each electron others become more and more bound, and this leads us to a drop of the probability of ionization, overall ionization. And as for chapter 3, indeed the numerical calculations that were carried out according to the formulas, they are given in chapters 4 and 5, so all the calculations of the spectra were carried out like that. And certainly I should have demonstrated it in a more obvious manner. That's it. Okay, thank you. Distinguished colleagues, all the reviews are already read and mentioned, and all the answers were given. So, distinguished colleagues, distinguished members of the board, is everyone satisfied with the answers? Yes, fully. Okay. So, is anyone willing to add up anything? No one? Okay. Questions submitted online during the broadcast. Do we have any questions here? No questions submitted by now. Okay, now we give the floor to the thesis supervisor. Please. Once again, hello everyone. Dear colleagues, I would like to say that the topic that Mr. Tumakov chose was novel not just for him, but for me as well. Because before Dima and some of my students started these studies, we did not work with the topic before. But the thing is that the experimental group, German group that we've been working together with, started to actively work on the topic, on this interaction of such ions with laser fields. and certainly the project is an ongoing one, and we don't have any significant experiments right now, but certainly we will see some. And we decided to work on that as well. And Dima is one of the students that started working on the topic, and as I learned, and as I didn't know a lot about this field, I asked Professor Tilnov from our department, who is a well-known expert in this interaction field. I asked him to help us, and he moderated our work and Dima's work as well. What else do I want to mention? Well, that is the first thesis on the topic under my supervision, and Dmitry is also a supervisor of this work. And certainly Dima worked quite well, and I would like to particularly mention that he was quite independent in his studies. Sometimes it worked to the detriment, because if Dima had a problem, we sometimes lost him, and I had to find him and to ask what went wrong. And suddenly he learned a lot, and you can see it in his answers. You see that he understands the field quite well, and I believe he is an independent researcher already. And I heard a question on going beyond the borders of a dipole approximation, and Dima is currently working on the topic as well. I believe that overall this thesis is quite a good one, and sure enough, he's ready to continue his studies, independent studies, and I hope that he will continue developing the topic, and I hope that he will continue doing that on our department. So I highly appreciate the results, and I would like to thank all the opponents, and also I would like to thank Mr. Tilnov, who was a co-supervisor for this work. Thank you. The distinguished colleagues, any one of the members of the board or anyone present, is anyone willing to deliver their reviews? Well, I would say a few words. I believe that this work is performed at a high level, and it is particularly important for our department. And I urge you to support this work. Anyone else? Okay. Now I have to announce a few formal words. As we hold our board session online, I would like to ask if the members of the board or anyone present have any questions connected with this remote access mode. If there are any questions, please feel free to ask. Okay, no questions. That is the question to the members of the board. Distinguished colleagues, now we have an opportunity to organize a short discussion to discuss the results of the defense. It will not be broadcast, and as all the reviews were quite positive, I believe we can skip this point. Okay, we won't organize it. So we don't need this as a great discussion. Therefore, we switch to open balloting, and all the opinions are given independently and openly. So that's not our case. That's not our case as well. Beg your pardon, I'm looking for the words that I need. Okay. I raise a question on the award of the academic degree to Dmitry Tumakov in Specialisation 010402 Theoretical Physics, and we're going to have an open balloting. So, please, Ilya Topitsyn. Yes, I support this thesis. Okay. Thank you. Then Professor Yerohin. I support the work as well. Then Professor Nefeldov. I also support the work. Then Professor Sorzhikov. I support the work as well. And I, Oleg Andreev, Chairman of the Board, also support this work. So thus, distinguished colleagues and dear guests, I would like to announce that 5 members of the board voted for the award of the academic degree. No one voted against and no one abstained from the vote. And the decision on the award of the academic degree of the candidate of sciences in specialization theoretical physics to Mr. Tumakov is made. Dear colleagues, as our session is organized online, I would like to ask if any members of the board or the candidate for the degree have any questions on the procedure. I need to get the answers. Ilya? No questions. Vladimir? No questions. Andrei? No questions. Andrei, no questions. Okay, no questions. And we give the floor to Mr. Tumakov for the finalizing remarks. First of all, I would like to thank all the members of the board for taking part in the defense. I would like to thank my thesis supervisor, Vladimir Shabayev, and I would like to thank Dmitry Telnov for this fruitful cooperation. That's it. That's it, what I wanted to say. Okay, thank you. And we congratulate Dmitry Tumakov with the award of the academic degree of the candidate of sciences in physics and mathematics. And I therefore close the session, and I thank everyone for participation. Kindly turn off the broadcast.